Hi guys, I thought I'd open the stream a little bit earlier just to double check that everything is working. Let me just double check on my end. Sorry guys. Alright, so it looks to be running through fine on my side. If you are in the chat, you can maybe just give me a thumbs up in the chat, not a like on the video. Just to let me know that audio is fine. So today we're going to go through the Free State paper. It was September 2025. Maybe I should just add Free State here. There we go. Okay, so it's the Free State September 2025 paper. September, if you look in the chat, I dropped a Google Drive link there for you that has got the papers and the memos in them. I'm going to mute myself until 3 o'clock when I check back in and see how we're doing. Hey guys, just quick check-in. We've got about 10 minutes before 3, and then we're going to start, and we're going to take it one thing at a time. Because it's paper 2, I was thinking let's start with organic chemistry and work our way all the way through. And I just want to check in how you guys experienced today's paper. I actually was pleasantly surprised. It was not as intricate, I think is the best way to put it, as I was expecting it to be. There were graphs, there were a bit of math application, but it felt to me much more like a physics paper than last year's paper 1 felt like. Last year's paper 1 kind of felt to me like an applied math paper. And even though I know that is what physics ultimately is, I don't quite agree with that being your grade 12 paper. But anyway, so I was just wondering if you guys could just drop me a message in the chat and let me know what you thought about today's paper. There is links going around that you guys can complete if you want to give feedback on how you experienced today's paper. I know for the Patea Heights kiddos it was sent on your broadcast group, so if you need me to send that to you, just let me know. So I'm just going to mute myself for another, I'll call it 8 minutes, and then I'll see you guys and we'll get cracking on this paper. Um, okay, I'm not going to start quite yet. I think we've got another 3 minutes left. Um, so just let me know if you guys have any opinions about today's question paper. I thought it was very fair. I've worked through the question paper. I've worked through question 2, 3, 4, and 5. I haven't done Doppler in those. I am pretty happy with them. For those of you who haven't pulled the papers and memos yet, you can have a look. I pinned the Google Drive link at the top of the chat for you guys. So you can click on that and have them electronically. I'm working through Free State September 2025 papers. I think that Free State sets really nice papers, sometimes quite intricate, and to be honest with you, if I compare the paper we worked through yesterday with the paper that you guys wrote today, I'm not saying it is exactly the same paper, but there were quite a few similarities, so I'm quite glad that we picked that Free State paper to work through. Yeah, so if you guys have opinions, you must let me know. Question 2, the Newton question, there was nothing strange there. I hope you guys all remembered that if a force is acting at an angle, it also influences the normal force, and anything that influences the normal force also influences the frictional force. The vertical projectile motion question, the first part of it was beautiful. The only parts that were a bit hard were the explanation of why it is inelastic, inelastic collision. Almost all collisions are inelastic anyway, so it was just there without doing a calculation to try and explain why that collision is inelastic. Momentum was fine. It was an interesting way of asking momentum, with a little baby bit of a graph, but it was again only really you had to redraw the graph and or calculate that initial velocity, but I still think they were very nice in how they extended that graph a little bit to try and show you where you were supposed to calculate that initial velocity from. What else? The work energy question I thought was really, really fair. Easy definition, easy first calculation. Possibly the only calculation that was a bit tricky was the part of the calculation that went down the slope with that frictional force. But all in all, that's the part of the question paper that I've worked out. I see absolutely no issues with it. I'll probably continue working it out probably tomorrow or Sunday. And if anyone is interested in that memo that I worked out, keep in mind it is not the official memo, it is simply my understanding of the questions and probably not necessarily the path or the process that you would follow to get there. But if you are interested in that, I really don't mind sharing those, as long as you guys understand that that memo is not the official memo, it is simply my best guesstimate of what it is. I also don't, when I mark my memo or my question, my script against the memo, I don't normally get 100%. There's always something that I miss. So, I just want to make that very clear. Alright guys, it is 3 o'clock. I want to go a little bit slower today for 2 reasons. One, This is aimed for the Protea Heights kiddos, and I know for the most part chemistry and you guys are not always friends, and you know how much that breaks my heart because chemistry is my big first love. And then also because, you know, you guys wrote a paper today. It was a 3-hour paper. You're what, halfway, maybe a little bit more through your exam session, your whole NEC exam, so I'm pretty sure you guys are getting a bit tired. And then I really do want to encourage you guys, I'm going to work through the question paper in order, unlike I did yesterday, so I'm going to go 2, 3, 4, and then the organic multiple choice questions, then I'm going to do rates and equilibrium and acids and bases with each of those multiple choice questions, and then lastly question 8 and 9. They're nice and simple, they're not very tricky, so I think those are nice to end up with. Yes, so I've got TPE Mitchell in the chat saying that I love the Free State. So my paternal grandfather, my dad's dad, actually grew up in Lindley in the Free State. So whenever there is rugby, provincial rugby going on, and it is Free State versus the Western Cape, where I am currently based, and where my dad also lives, it is definitely quite an interesting rugby match. But yes, no, I'm absolutely, I have spent some time visiting the Free State and Free State schools. I have great respect for the resources that your province creates, very well thought out, very, very correct, and also your question papers I really do think are of a high standard without being ridiculous. They stay within the curriculum, and I think that's very important, you know, to challenge you guys, but not to try and catch you out around every corner. You know, I think it's a very well-balanced paper. So yes, I absolutely adore the Free State and the Physical Sciences Department in the Free State. Having said that, I live in the Western Cape, and I'm extremely happy to live in the Western Cape. Both my parents are in the Western Cape, and the school I absolutely love with every soul, every cell of my being, is also in the Western Cape, so I'm very happy here. But yes, okay guys, so I think let's get started, otherwise we're going to be here until midnight. For those of you who don't know, I'm going to do the whole, my first name is Mariata Vermeulen. So I am a physical sciences teacher at Protea Heights Academy in the Western Cape, in the northern suburbs area. So we're doing the stream mostly for our physical sciences learners, because my physical sciences learners don't all fit into a Google Meet. There's too many of them, I'm very proud of that. But so we do the stream for them so that they have a revision session and don't have to come into school, although my class is free and open and welcome for them. I'm currently sitting in my classroom. So very much welcome, grade 12s, and I hope that today was a fair paper, that you experienced it as fair. It looks to me as fair, and that we do a little bit of work and get ready for paper 2, so that paper 2 doesn't do something silly to our marks. Chemistry is my first big love, so I am very biased towards chemistry. You guys are going to have to excuse me. Alright, so just again, please watch the chat. I don't mind that you guys interact with each other. I really actually love it, because maybe I say something and it doesn't quite make sense to you, and then someone in the chat will understand what I meant with what I said. And also please remember that the chat is slightly delayed on my side, so I do try and just stop. And then those of you who don't know me personally, I'm severely ADHD, and the more excited I get, the faster I go. So Joshua is in the chat to constantly remind me that I am allowed to calm down and go at normal human speed and not at 2.5 YouTube replay speed. Alright guys, so we're going to start with organic chemistry, then we're going to do the middle section, and then we're going to do the final electrochemistry. Okay, and we're going to try and get through this, and Obviously the video will be on YouTube, it's not going anywhere, so you are welcome to go back and forth. Okay, so let's get going. Question 2. I have a strong suspicion, unless the Department of Basic Education does something incredibly strange, that your question 2 on Monday will look something similar like this, that you will have a table, 6 to 8 compounds, and that in this situation that you'll have to analyze these and then answer questions. So what I always do is I analyze these first, okay? And I'm going to show you what I do in my brain. I am one of those who have to write it down, but we'll have a go at it. Okay, so for A, they give you a condensed structural formula. I really struggle with condensed structural formulas. I have to actually write them out. So I start on this side and I'd go CH3, and then I've got that CO, and then I've got a CH, and then there's CH3 in a bracket with a 2, which is those two. You'll see when I'm jotting down the structural formulas, I don't write the H's because, well, they are a pain to write out, and I'd rather save my hand for when I'm asked for a structural formula and I have to write it out. This is just my thinking. So that double bond there means it's a ketone, and if I look at it, I'm trying to get that double bond oxygen on the lowest possible carbon. So I go 1, 2, 3, 4. So that methyl group 3, methyl butane 2-one. And because sometimes we have isomers in here, it's always useful to just quickly jot down what the molecular formula for this thing is. So I got C5H10O. Alright, B, they give me a name. I'm better with names for some other reason than I am with condensed structural formula, but I still like the picture. So what I do is I draw my hexane out, and then they say it's 3, 3, so there's 2 methyl groups on carbon number 3. It's an alkane, and very quickly I just jot down what that molecular formula would be in its most condensed form, if that makes sense. Alright, for C, they give me this huge diagram, and when I counted, I realized that 5 carbons is my longest chain, and I was pretty comfortable with that methyl group there, that methyl group there, and that methyl group there. And then instinctively, I don't know why, I counted top left down. And then when I analyzed it, I realized that if you count bottom up, that your numbering systems are better. So just to show you that, if I count from the bottom up, I get 2, 2, 4, tri, because there's 3 of them, methyl pentane. Where if I count from the left down, then I get 2, 4, 4 trimethyl pentane. If I go 2 plus 2 is 4, plus 4 is 8. So those little substituents give me 8, where 2 plus 4 is 6, plus 4 is 10. So this bottom one gives me a bigger number down here, which means that top one is actually the correct way of doing it. Then for D, they give me another complete structural formula. That up there jumps out of me, that formal group up there, and so that means that this is going to be carbon number 1, nice and easy, 1, 2, 3, 4, 5, which means I'm dealing with pentanol. And if I draw the if I do the molecular formula, you will instantly notice that D and A have the same molecular formula. So I instantly know that D and A are isomers. Right, okay, I'll get to E now. Okay, there's a reason I left it for a moment. If propan-1-ol, also I'm quite comfortable with names and structures. So again, prop is 3 propan, single bonds, 1-ol, alcohol on the first group. And then that molecular formula there that is not like any of the other. So at the moment I have that B and C have the same molecular formula, and that A and D have the same molecular formulas. And generally when something like that happens, you know they're going to ask about it. Okay, so this molecular formula is not incredibly useful. What I did notice is that there's 2 oxygens there, and there's only 2 of the functional groups that we deal with in grade 12. Don't quote me when you go to first year and you do organic chemistry. In grade 12, there's only 2 functional groups that have 2 oxygens in them. Those are esters and carboxylic acid. So I know that E is going to be one of those. Again, this is something I do before I even start worrying about the questions. I go through that table, I analyze the table, I figure out what I'm dealing with. Okay. And this is like my little extra baby crib note that I'm going to hang on to when I start dealing with the questions. Okay, so let's start dealing with the questions. And you'll notice now that I've already answered most of these questions for myself. Alright, so they say write down the letter that represents an aldehyde. So that is number D, that is pentanol. Then 2.1.2, write down the letters that represent functional isomers. Alright, so firstly, when I did my analysis, I saw that I had B and C that were isomers of each other, and A and D that were isomers of each other. However, B and C are both alkanes. They simply have different putting together of chains, where A is a ketone and D is a aldehyde, and so those are functional isomers. I want to remind you that for functional isomers, you are dealing either with an aldehyde and a ketone, or you are dealing with an ester and a carboxylic acid. So the 2 functional isomers are A and D. Alright, then they ask for a carboxylic acid, and here is where this analysis now really helps me out, because ketone, alkane, alkane, aldehyde, alcohol. That means that E has no choice. E has to be the carboxylic acid. Alright, I hope that makes sense. That's kind of why I go through things, and when I'm not sure I go, well, it could be, but let's see what happens with the questions. Alright, so those first 3 I thought very easy, very fair. Okay, 2.2, write down the general formula of the homologous series to which B belongs. And you will remember that when we analyze that table, B is an alkane. The general formula for alkane, CnH, 2n plus 2. Guys, those are very easy questions that I really don't think you should not get all the marks for, please. Whoops, sorry. Just made you guys go all weird and upside down there. Okay, so 2.3, we are going to look at compound C. Just a reminder, compound C was the one where I had to be careful where I counted from. It's the trimethylpentane. Okay, so write down the letter of the molecule that is its structural isomer. Okay, remind you, in grade 12, all the isomers we have are structural isomers. Right. So I'm going to find the letter of a molecule with the same molecular formula, and because we've analyzed it, that goes easy. That is molecule number B. Now they ask a follow-up question. What type of structural isomer? Going to remind you, we have 3 options. We have chain isomers, in which I cut carbons off and paste them on new spots. I have got functional isomers, so I change the functional group. The combos there are aldehydes, ketones, carboxylic acids and esters. And the other option I have is positional isomers, where I move the position of something other than a carbon. In this example, okay, if you look at the name, we had 3,3-dimethylhexane, and now suddenly, instead of having 3,3-dimethylhexane, we chop a little bit more of the long carbon chain off and we stitch it on somewhere else. And so this would definitely be a chain. Whoops. Isomer. Okay. Then the IUPAC name of C, and this is where it is incredibly helpful. You have done all of this work beforehand. Then just let's have a look. There we go. 1, 2, 3, 4, 5. I've counted upside down and left and right. Those are the most carbons I find. Again, if I count from the bottom, it's 1, 2, 2 methyl. Can you see that? And then the other methyls on 4. If I start somewhere at the top, then it's 1, 2 is my 1 methyl group, and the other 2 methyl groups are on carbon number 4. Right, so like I say, I find it really does help if you just take that moment before you start writing a question to just analyze what the question wants. That is why you have the 10 minutes reading time. I know it is frustrating that you don't have the ability to scribble your thoughts down during that reading time, but that is the rules of the game. Right, so just a reminder, you must have a comma between each number, and you must have a dash before and after numbers. Right, so I don't have a dash here because there's no naming before this, but I must have the dash after. Alright, so commas between numbers, dashes before and after numbers. Okay, then we go to 2.4. For compound A, write down the structural isomer of its, structural formula of its chain isomer. Now I had a look at this question and I am very sorry, but A does not have a chain isomer in the table. Alright, that was my first thinking. And then I realized, no, hang on a second. All they want me to do is they want me to take A and they want me to take that little methyl group off and plonk it on one of the two sides of the carbon chain and make it a longer carbon chain. That's what they want me to do there. Okay, so they want the structural formula. So I'm going to just start by drawing what I assumed from the name was the longest carbon chain, right? And now from the name there was a methyl group here, and instead of putting this methyl group here, I'm going to take this methyl group and I'm simply going to add it on the other side. There are two options here. You could either add it on what I did my left, or you could have taken it off there and added it on the right. Okay, so either of those are correct. Now I draw the carbons, then I count to 4 on every single carbon. So carbon 1, 2, 3, 4, carbon 1, 2, 3, 4, carbon 1, 2, 3, 4. If you don't do that, you guys make mistakes here. Carbon 1, 2, 3, 4, carbon 1, 2, 3, 4. And now everywhere where I put a line, I put a hydrogen. And this is where you guys might be able to see my dysgraphia pop its ugly head out. Anyway, alright, so that would be it. Keep in mind that if even one of your lines, or one of your bonds from a carbon is not completed with a hydrogen, you get 0 for the entire thing, even if everything else is 100%. So please don't do that to yourself. Rightio. And then 2.5, the last part of question 5, question 2, I thought was a really nice, easy question. They say compounds E and F react to form an organic compound. They told me by sort of randomization that E is the carboxylic acid, and if I look, F is a primary alcohol. Ladies and gentlemen, when an alcohol and a carboxylic acid react, we form esters, and so the process is called esterification. Oh my greatness. Okay. Then they ask me for the name or formula of the catalyst used. You might have guessed it, even if you don't quite know me. Formulas generally are not that hard to get wrong, where words and I are not great friends. Okay, now the IOPAC name. So if we look at E, you guys can see there are 2 carbons in E. And so because I now know that this is a carboxylic acid, I can say that that is ethanoic acid. And that guy is propan-1-ol. And when we combine them, it goes propyl ethanoate alcohol carboxylic acid. So the organic compound that is going to form is going to be called propyl ethanoate. Right, it's not the only O-weight that forms in real actual organic chemistry, but for our purposes in grade 12, that would be the complete, or the only place that you would see that O-weight is formed from a carboxylic acid. Alright, I don't think there was anything strange on question number 2. Guys, question number 2 really is a question that all of you, like, there's no one that I have taught in all the years that I've been teaching that cannot get very, very good marks for this question paper. It is simply a case of studying and then practicing. It is that simple. Okay, before I do the multiple choice for organic chemistry, I'm actually going to do all the organic chemistry questions. And then I'll go to the multiple choice questions. Okay, so this is question 3, the boiling point question. Again, they give me a table, and I prefer to analyze this table before we then start dealing with the actual questions. So, they have boiling points of 4 organic compounds are shown in the table. They give me boiling points, they give me molar mass. I always wonder, why do you give me molar mass? And then I see that all these molar masses are similar, or you can say they're comparable. So this is obviously important. And then obviously boiling points because, you know, physical properties. And then I have a look at these compounds. And I see that compound A has got that COOH, which means it is a carboxylic acid. B has got an OH, so it's an alcohol. C also has an OH, so it's an alcohol. And D has that O oxygen smack bang in between 2 carbons, which means that is a ketone, right? And so because I've got 2 alcohols, I just quickly did a strict drawing of the 2 of them from these condensed formulas. So CH3, then there are 3 CH2s, 1, 2, 3, and then the OH. So you can see this is a straight chain primary alcohol. Then for C, there's the CH3, there's the CH. Let me do that. There is the CH. And then this in bracket shows me that methyl group. Then there is that CH2 and that OH. So you'll notice that C is more branched than B, and that's going to be important, especially since there's a whole boiling point missing. Okay, so just quickly I went through it and I went, okay, we're probably dealing with maybe the branchedness of the chains, and then for this table, definitely the type of intermolecular force, because the homologous series or the functional group, they are constantly changing. Alright, then typical question, typical definition, boiling point. I just want to point out to you guys that these definitions are not with the rest of organic chemistry. It's just before. You find it on page 16. The 3 definitions that they like to ask in this question again, I'm not saying they will ask them, I'm just saying they like asking them, is boiling point, melting point, and vapor pressure. So just go make sure you know these. Boiling point is the temperature, not the point at, not when, the temperature at which, there we go, the temperature at which vapor pressure of a substance equals atmospheric pressure. You don't have to add this tail on, it's simply for you for explanation. So the temperature at which vapor pressure is equal to atmospheric pressure. Okay, very simple. You guys have had that definition since last year. Okay, now they make a statement. They say compound C's boiling point is lower than that of compound B, right? And then if I look at C and B, I go, oh yeah, okay, hang on. This oak is more branched. So this molecule is rounder. There's less surface area between the molecules of compound C than there are between the compounds of B. B is nice and long and flat, so there's a large surface area that is in contact between molecules of substance B. Alright, then they do the whole fully explain your answer. The last few years they've been adding refer to here. They might do that on Monday, but I cannot guarantee you that. Okay? The rule I always say is you start with what type of intermolecular force are you dealing with. Then you say you either go length or mass, molar mass, right? But here they also have the same molar mass. Then you go to how branched are they. So I'm going to say that again. First thing you look at is the type of intermolecular force. The second thing you look at is the molecular mass, okay, or the chain length then ultimately. And the third thing you look at, if they have the same type of intermolecular force and they have the same number of carbons, then you go and see how are those carbons put together. Alright, so I said that B and C are both alcohols, and that means that they both have one site of hydrogen bonding. They also have the same molecular mass. Right? I don't know if they're going to give marks for that, but if they're going to give marks for that, then at least I'm not losing those marks. Then I go and I tell them, now what's different? So I say to them, the C is more branched. And what happens when something is more branched? There's a smaller surface area. And now I want you guys to just listen carefully. They don't like us using IMF for intermolecular force. But if you say for intermolecular force and then you put IMF in a bracket, then, ladies and gentlemen, you are allowed to IMF all the way through the question. Okay, so the first opportunity I get in question 3 to do that, I go, that's the intermolecular force, which from now on forevermore in this paper I will shorten as IMF. It really does save you quite a bit of time. Okay, so more branched, smaller surface area. Smaller surface area, weaker intermolecular force. Weaker intermolecular force, less energy required, lower boiling points. Okay? So you argue why the intermolecular force is different. Then you say weaker intermolecular force, less energy to overcome, lower boiling point. Alright, always this last statement here. Right, so again, not a strange question, nice and easy question. I don't think there was anything weird on that. Okay, now they compare A, B, and C. So for the first experiment, they compared B and C, the two alcohols, and now they are comparing A, B, and D. That's probably why they left that out. I kind of went, oh right, okay. So we're going carboxylic acid, alcohol, and ketone. Alright, and now these type of questions I generally have to answer other way around because I've got to argue why something happens first. But they tell me that the boiling point of C is bigger than the boiling point of B. They told me that in question 3.2. Okay, so the boiling point of C is 108. So that doesn't eliminate any of these. And then if I look at the theory, I know that carboxylic acids have stronger intermolecular forces than alcohols. Why? Because there are two sites of hydrogen bonding in a carboxylic acid or between two carboxylic acid molecules versus one site of bonding for two alcohol molecules. Okay, and so I realized that I can comfortably say that B's boiling point will be lower than A, and I kind of looked at that 141 and I was like, that's not really lower now, is it? So because 145 is bigger than A and 141 is basically the same as A, I said the answer is 117,7. Alright, now for 3.2 they say fully explain your answer. For a lot of marks, and I realized that if you read the question in its essence, all that they are actually telling you to do, right, very simply is explain why the boiling point of B is smaller than A, and explain why the boiling point of B is bigger than D. Alright, that's why it's so heavily marked. Okay, so again, I always start by saying what is its functional group or its homologous series, and what type of intermolecular force am I dealing with? So, A, carboxylic acid, two sites of hydrogen bond, fact. B, alcohol, one site of hydrogen bonding, fact. C, ketone, dipole-dipole, fact. All three these are fact, right? Now I argue, why does B have a boiling point that is smaller than A? So I say A has stronger intermolecular forces than B. I said that there are two sites of hydrogen bonding versus one site of hydrogen bonding. So A has a stronger intermolecular force than B. That requires more energy. A requires more energy to overcome, and therefore A has a higher boiling point than B. I am making it so blatantly obvious what I am telling them that even if I fumble over my words in the explanation, they really cannot start going, maybe I won't give you the mark. Okay. So that is my explanation for why A has a bigger boiling point than B. Now my second explanation is why does B have D has a lower boiling point than B. So I said that D is a weaker IMF. I've already said that D has dipole-dipole, B has hydrogen bond. All I'm telling them is that D, the dipole-dipole, is a weaker intermolecular force than B, the hydrogen bond. And then again, I tell them the weaker intermolecular force requires less energy to overcome. And if it's less energy to overcome, it will have a lower boiling point. Okay. Remember that this in-between boiling point is not something they gave you. Right, again, I don't think it's a horrible question. I think it's quite nice. It is very mark heavy. But I think that this question really does give benefit to learners who actually truly have worked hard in physical properties of organic molecules to understand the theory and how all of it fits together. So I'm going to be honest with you, I have no issue with that explanation being as mark heavy as it is. Alright, then we are going to look at question 3.4. So now they go completely away from the previous table. And I'm going to be honest with you guys, we did something similar in Metro East, the September paper, but instead of having a different table, what we did, let me find the original table, is we kind of had them as here's experiment 1, here's experiment 2. And I know our learners struggled with that. They weren't quite sure which experiment was which. So again, if you guys ever, your teachers, ever chat to whoever is in charge there in the Free State, I really do think that you guys, your department puts a lot of energy and effort into setting papers, which I personally think is very important. Alright, so I've got a question in the chat. Those of you who did come in a little bit later, I am streaming from a streaming software, so I'm not streaming directly onto YouTube. So what that does do is I have a bit of a chat delay. I've got the chat open in front of me, so if you do ask a question, just hang tight. I promise I'll get back to you. Right, so Byron's asking, do we draw compounds in pen or pencil? I cannot speak for the other provinces, however, I do know that at NSC level, for the marking, we try and mark very consistently across all provinces. The rule in the Western Cape is that if you can read it, you must mark it. So whether something is written in pen or in pencil, if it is on the paper and it has a question number next to it, we mark it. Alright? You generally don't get your scripts back unless you pay to view your script. It's not like you have the opportunity of quickly erasing an answer and writing the correct one and then arguing that it was marked incorrectly. As long as we can read it, we will mark it. I would like to just warn you guys on that point, the erasable pens, just be careful of those. The ink literally disappears under heat. It's not the friction that rubs the ink out, it's the heat that dissipates, I think is probably the correct word, dissipates the ink. So just be careful when you're using that, depending on which part of the country you live in. Your papers go into a delivery truck and then go from school to school to school to school to school, and then go to your district or your provincial offices. So your papers are going to get hot. Those trucks are not air-conned. So I always guard against those, but pencil doesn't do that. And we mark pencil, so if you feel a little bit safer doing your diagrams in pencil, that's absolutely fine. I cannot speak for other subjects, though. I don't mark other subjects. Alright, so for 3.4, we've got compound E, F, and G, and they very clearly state that these are 3 straight chain alkanes. Alright, and E has got 2 carbons, F has got 3 carbons, and G has got 4 carbons. So we can very clearly see that this is ethane, propane, and butane. Alright, so increasing in molecular mass and increasing in chain length, any of those, whichever way you argue it, that works best for you. And just be careful, they give you vapor pressures here and not boiling points. Okay, write down the IUPAC name of the compound with the highest boiling point. We know that boiling point is inversely proportional to vapor pressure, and I don't know if that's quite the right way of saying it, but basically, if the boiling point is big, then the vapor pressure at a specific temperature is low. Alright? So they swap around, which I suppose is inversely proportional, but yeah. So if we want to write down the compound with the highest boiling point, we need to find the compound with the lowest vapor pressure, and that is this C4H10, and they're asking for the IUPAC name, so my answer is butane. Just be careful now when you go to 3.4.2. Originally, when I was working through the question paper and prepping, I kind of thought, I don't know why, my gut instinct was to just explain why I said that. And then I saw that they actually said it fully explained the trend in vapor pressure in the compounds. Okay, so if they ask you to explain your answer, then you can refer to it has the lowest vapor pressure, and vapor pressure, a larger vapor pressure is equal to a lower boiling point, whatever on. But here they ask you to explain the trend in vapor pressure from E to G. Now you'll notice that I follow a similar process than I did when I dealt with A, B, and D. So I start by saying E, F, G are straight-chained alkanes, and they all have London intermolecular forces only. I can use IMF because I've already told them earlier in the paper, IMF is equal to intermolecular force. Okay, now, I struggled a little bit to verbalize what I wanted to do. And originally I thought, well, I'll go and explain why E has the highest vapor pressure and the lowest boiling point. And then I realized that they asked me for a trend. So I'm going to be very honest with you guys. While I was prepping, I thought that that little middle paragraph would be my big explanation paragraph. And then when I read through the question paper again and I checked my thinking and I checked the memo, I realized that this only explains why E has the highest vapor pressure and lowest boiling point. This does not explain why there is a trend. Okay, and so I then did my whole second attempt. Okay, and so I think if you're explaining a trend, it's much better to explain what is happening throughout the table. So I then said, as the chain length increases from E to G, the surface area for the intermolecular force increases. This increases the strength of the intermolecular force, which increases the energy required to overcome the intermolecular force. That causes increasing boiling points and decreasing vapor pressures. Alright, so like I say, I, in hindsight, would not recommend that middle paragraph because it only explains what's going on in E, where my little second baby paragraph is much better suited for the question. Now, if you are done with your question paper and you're stuck in a situation where you like that, you need to realize that they're going to mark this paragraph first, and the second they go, no, that's not what I wanted, they're not going to just mark this paragraph because it's there, okay? They're going to do what I did here. They're going to write next to it second. They're going to mark this paragraph. You might get a couple of points from it. So when you are doing like I did and you read through your answers and you go, no, that's not the right answer, guys, please don't scratch things up. Take a ruler, take a pen and go 1 or 2 or 3 lines, just a few. That means don't mark that. Okay, it really is that simple. This one was also less marks than the previous one, so yeah. Okay, nice and easy question 3. I really liked this question 3. It tested all the parts of it without making it horrible. Okay, last organic question. If you get seasick or get motion sickness, do me a favor and quickly look away from your screen because I'm going to jack up my visualizer and then the screen looks like it's moving and you're not, and then you guys are all going to get all angry at me. Okay. So, yeah, there we go. It's in. Alright. So, question 4, always organic reactions. Now, again here, I know there's so much in the organic reactions that you guys need to master. I know it. Guys, really, please don't think for a second that I don't realize what we are asking of you. But again, just like question 2, question 3 are marks that you definitely can get. So if I'm looking, question 2 is out of 17 and question 3 is also out of 17. So that's 34 marks. Add the 3 multiple choice questions. That gets you to 40 marks. And then let me just quickly look. Add another, sorry, it's off the screen. Add another 17 marks here for question 4. Guys, you're looking at a pretty decent chunk of your question paper. Okay, and if you can just do well in the organic questions, if you are worried about passing the question paper, then that's where you score your marks. You know, it's okay for us not all to be brilliant in chemistry. It's fine. Okay, so again, just like with the table for question 2, and just like with the table we got of the boiling points, vapor pressures for question 3, I do a quick little analysis, and I especially do it here, okay? And I would write all of these things on my question paper. Remember, there is no rule that says you are not allowed to write on your question paper. There's no rule that says you cannot write in color on your question paper or highlight. You can molgen. You really can take that question paper and make it yours, okay? The only thing you are not allowed to do in your script is do a whole bunch of weird, wonderful colors. Okay, if you have time to do epic title things for your question, then you better be getting like 90-97%. Because that time that it takes you to do is time that you could go and rework out some of these things and catch yourself making mistakes. So I really do expect of you guys to rather put your energy and effort in the content and not in the presentation. Okay, I promise you the markers, we are interested in, can you logically clearly put out what your brain is thinking. Okay, so flow diagram shows a number of organic reactions. Reaction 1 is cracking, so I write it in. I know that during cracking, an alkane and an alkene form, right? That always happens with cracking. Cracking, I take an alkane, I split it, not necessarily in half, but I split it and I get out an alkane and an alkene. All right, I know that. So when I went here, I went CH3, CH2, CH3, and I quickly jotted down that molecular formula, and I saw that is definitely an alkane, which means that that guy is an alkene. Okay, I'll get to how I figured out its propene in a second. Alright, so that's an alkene. Then again, I take a step back and I look at my diagram, and I see that O2 there. The only place in any of the reactions where we use O2 in organic is when we do combustion, right? And so we have two things that form, and combustion is when we take a carbohydrate, sometimes with an oxygen in, they work just as well formula wise, and sometimes they do better in like actual real life in terms of energy release. And so I know that one of my compounds is going to be carbon dioxide and the other one's going to be water. I didn't know which was which here, I just kind of had it in the back of my brain. Alright, so I've dealt with that part. Now, I know that this is an alkene, and then they say here reaction 3 and they go HBr. So ladies and gentlemen, if you start with an alkene, it is always an addition reaction. If you start with an alkene, it is always an addition reaction. If you end with an alkene, it is always elimination. Start with an alkene, addition. End with an alkene, elimination. No alkene, possibly, most likely, substitution. Okay, right. So I knew that this was addition, and that HBr there said to me that it was going to be hydrohalogenation. Okay, all just scribbling. I don't even know what the questions are yet. Okay, so then when I followed this arrow down here, I saw that 3 carbons there. And the only place where carbon chains are chopped shorter or completely disintegrated is here with combustion or there with cracking. Which means these 3 carbons had to come from compound R. And so the fact that there's 3 carbons is how I knew that this alkene had to also have 3 carbons. So this would have to be propene. Alright, so that's where that propene came from, the 3 down here. You'll notice that everywhere where I jotted down a name of a compound, it's highlighted in gray because I picked it up from that 3 carbons over there. Alright, so dealt with reaction 3 and managed to get an idea of what alkene compound R would be in the process. Okay, let's follow on. I've got a halo alkane, I've got reaction 4, and I end with an alcohol. So haloalkane, alcohol. The only option here is substitution. Of course, you can call that hydrolysis as well. I get a bit confused because hydrolysis could be other things as well, but you know, let's just, okay, cool. So that is an alcohol. Again, I know that there are 3 carbons there, so that guy has to be propanol. Haven't figured out where the alcohol goes, the hydroxyl group goes yet, but that's fine, that's not the issue. Okay, now my alcohol reacts with H2SO4. H2SO4 is a very, very, very fun compound that is very, very good at removing water from very many things. Okay, now, if I had an alcohol and I was doing another substitution reaction, right, then I would need here a halogen involved, and I don't. So I instantly knew, because I don't have a halogen here somewhere reacting, that this was going to be my dehydration reaction. Okay, inorganic, organic. So I know that that guy up there, compound R, my organic compound, is going to be the alkene. Now when I dehydrate, I remove water, and keeping in mind that I've already done this thing going which is water, which is carbon dioxide, and that then there managed to help me sort that out. Okay. The only other thing I did, and you don't have to do that because you don't need it, but compound Q, this alkane has got a molecular formula C3H8, and this propene has a molecular formula of C3H6 because it's an alkene. The compound Q gets all its carbons from this alkane and compound R, so 3 plus 3 is 6, and it gets all its hydrogens from the same 2 places. 8 plus 6 is 14. Like I say, that little step there ended up not mattering, but you know, I always like to kind of really have a picture of what's going on. Okay, so let's get to the actual questions now that we've analyzed the table. So first question, define the term cracking. So very simple, chemical process, longer chain hydrocarbon molecules broken down into shorter molecules. You don't have to say that they are more useful. They're looking for, it's a chemical process, longer chain hydrocarbon molecules broken down into shorter molecules. Okay, right. Now they tell us to consider reaction number 2. Reaction number 2. What type of reaction is it? Endothermic, exothermic? Again, when I saw that oxygen there, I was like, ooh, 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 combustion. Combustion, ladies and gentlemen, is how the modern day combustion engine works, and so it has to be an exothermic reaction. Alright? Then, using molecular formula, write down a balanced chemical equation. This is the only chemical equation, I think. I might be wrong, they might be weird, but most of the chemical reactions that they give you guys in paper 2 is already balanced. So this is the one that you definitely have to be able to balance. I want to point out to you that if you can write down the alkane plus O2 gives me CO2 plus H2O, reactants and products, you will get 2 out of the 3 marks. The balancing is only worth 1 mark. If you struggle to balance, leave it out. Write down whatever alkane you are dealing with, which in this case, sorry guys, is given. So alkane plus O2 gives me carbon dioxide and water, Okay, there's no excuse for you guys to not get at least 2 out of 3 marks there, even if balancing really is something you struggle with. Alright, then they say write down the name of compound S. Again, now this question for me in this situation is easy because I've already done all the analysis. I already know that T is going to be the water from this dehydration from here. Okay, so I really do think it is just worth quickly going through that diagram and making sure that you know exactly what is potting in which part of the diagram. Okay, okay, so that was reaction number 2, the combustion reaction. Okay, then we go on to reaction number 3. Reaction number 3 is this guy down here, where compound R, which we have managed to figure out is propene, reacts with hydrobromic acid. Sure, that's a name. And then forms a haloalkane. Right. So write down the type of reaction. Now this is an incredibly broad question, so you can either write down addition or you can go more specific, hydrohalogenation. Remember that often time is not your friend, so addition is a good thing to write down because it's easy. Then 1 reaction conditions. The first thing that popped into my mind is that if we want an alkene to not form an alcohol, we must make sure there's no water in the system. Now, for the Free State paper, they completely accept it as a reason, but I have seen provinces where they don't. So I'm always hesitant to write that there must be no water in the system, or the system must be anhydrous or something like that. I know that some textbooks, rather than saying an unreactive solvent, says a polar solvent. I would be a little bit careful of saying polar solvent and rather go with unreactive solvent. Yeah. Then the IUPAC name of compound U. Okay, so now here's where Markovnikov's rule starts sticking its head out. For those of you who are not very familiar with Russian literature, Markovnikov's rule is the same as saying hydrogens are the life of the body. So, if I have a carbon with 2 hydrogens, and one of the things I am adding is a hydrogen and the other one is not, then hydrogen will go on this carbon where there's already more hydrogens. So hydrogens are the life of the party. So I am a little bit careful to use blue and green. Those of you who are not regularly in my classes, I'm quite careful because I do know that a number of people in physical sciences, the way your brains work sometimes weirdly coincides with being colorblind. And I do know of a learner in PHA that is colorblind. So I'm sorry if my colors clash, but I'm doing it very purposefully to make sure that I don't confuse someone that I don't need to. Alright, so I'm going to say that hydrogens is the life of the party, so it's going pinkish. It depends on what my visualizer is doing with the colors. Then, not the weirdest color, blue will work. Okay, so bromine is going to be blue. Right, so hydrogen goes where there is already more hydrogens. And then the bromine will go in the other spot. Right. Hydrogens will go to the carbon where there is already more hydrogens. Now, I'm going to point out that this was not the question. They asked for the IUPAC name, but I need to know where that bromine goes before I can give the IUPAC name. So, this is propane, and the bromine is attached to the middle carbon. Doesn't matter from which direction you count, it's going to be on carbon number 2. So it's 2 bromo pro Propane. Alright, 2 marks probably, 1 for the 2-bromo and 1 for propane. Alright, now we go on to the next reaction. Reaction number 4. So reaction number 4 was the substitution reaction here, where we converted a haloalkane. Yes, a haloalkane to a alcohol. Sorry guys, sometimes my brain doesn't want to see a word and then I can't pronounce it. Okay, so the first thing is the structural formula of the alcohol formed. Now again, you are going to have to keep in mind where that alcohol came from. Alright, so this comes from there. And when we do substitution, what happens is I pull the halogen off and I put the hydroxide on. Okay, so I'm substituting. There where I pull the halogen off is the exact same space where I plug the hydroxide on. Alright, so there is the structural formula of that alcohol formed. Right. And then they ask for the type of reaction. Again, here it is open-ended. Okay, it is not like they've got a question down here later. It's an open-ended question, so you can either write substitution, which is definitely what I would be writing, or you can write hydrolysis. Like I say, I would definitely be writing substitution. Okay, and then the last reaction on our little diagram. I say little, this is not a little diagram. For reaction 5, we have an alcohol, and we add sulfuric acid, and we get an inorganic compound and a organic compound. And from here, we know that that inorganic compound is water, and so this has to be dehydration. All right, so for reaction 5, write down, and here I want to point out that here they don't just go the type of reaction. Here they want you to say specifically what type of elimination reaction. Here you have no choice, you must write dehydration. And then they ask the IUPAC name of compound R. Now again, just remember, Markovnikov's rule works backwards as well. So if you have to remove a hydrogen, the hydrogen will come off the carbon that has the least amount of hydrogens. But here, it doesn't matter, because you're going to pull this hydroxyl group off, and whether you pull that hydrogen or that hydrogen off, your double bond is still going to be between carbon number 1 and 2. Because the double bond can only be in one place, you do not need to name where the double bond goes. However, you are free to do so. Alright, that was question 4. I don't think there was, like, it's tough, guys. Like, these are not superficial questions, but I really don't think that they are ridiculously hard. I think they are very fair, and I really do hope that for your paper tomorrow, I really do hope that you get questions that test your knowledge, but that are fair. I mean, I can't ask for more than that. Okay, let's have a look. The multiple choice questions, 1.1 to 1.3, are the organic questions. Which one of the following is unsaturated? So ladies and gentlemen, when they ask this question, unsaturated means you are looking for an alkene or you are looking for an alkyne. If you find an alkane, it is saturated. So if you look there, that is the general formula for an alkane. So A is saturated. Then, if you count here, you've got 1, 2, 3, 4 carbons and 6, 7, 8, 12. Did I count right? No, I didn't. 1, 2, 3, 4, and then 3, 2 is 5. Yes, 5, and 3 is 8. So this guy is C4H8, and that there tells me that this is an alkene. So at the moment, the most obvious answer looks to be B. I'm just going to double check. If I add all of these together, again, I get a C4H10 situation. And here I've got 1, 2, 3, 4, C4H. 3 plus 2 is 5, plus 2 is 7, plus 3 is 10. So because of those molecular formulas, the general formula jumps out quite quickly, which means the answer cannot be C, it cannot be D, it has to be B. Quite nice and easy. Okay, then for 1.2, they give me, consider the organic molecule below. So 4 carbons, 8 hydrogens, and 2 oxygens. I pointed out to you guys in question number 2, the 2 oxygens means either carboxylic acid or an ester. Alright, so it cannot be an alcohol. Butanoic acid is a carboxylic acid, and these two are esters. So if I just work off carboxylic acid and esters, it could be any of the 3, but it cannot be A. And then I want you to notice that this thing has 4 carbons exactly. Butanoic acid has 4 carbons. Methyl is 1. Butanoate is another 4. So C, that name, is a compound that has 5 carbons in. Same here. Ethyl, 2 butanoate, 4 means that the naming of D has got 6 carbons in. So it cannot be C and it cannot be D. Again, it has to be B. And again, here I'm sitting in the question paper, blind panic, because the first 2 answers are B. And if the first 2 answers are either B or C and they're both the same, I start worrying. But that's okay, it's just me. Alright, then 1.3, organic structure. They want the IUPAC name, careful of the functional isomer. Alright, you will see that I highlighted there in grey the functional group. This is an ester, which means we need to write down or pick the IUPAC name of a carboxylic acid, which means it cannot be A and it cannot be C, because A and C are names of esters. And now I go and check and I count that I've got 1, 2, 3 carbons, which means it's not ethanoic acid but propanoic acid. Can you guys see how here I would be writing this question paper and these multiple choice questions would send me into a blind panic attack? I am so grateful that I finished grade 12 many years ago. Alright guys, so that's all the organic. Right, now I know I have been doing chemistry for a while longer than you, but it is about 4 o'clock, a little bit after, and we've spoken through all of this. So I really don't see any reason why you guys can't go tomorrow, Monday, and ace your organic questions. Okay, just take some work. Okay, cool. Now, question 5, rates of reaction. A factor influencing the rate of a chemical reaction is investigated by conducting 2 experiments, 1 and 2. We've got magnesium and hydrochloric acid that gives us magnesium chloride and hydrogen gas. In both experiments, the same mass of magnesium is used. So can you guys see? Here we have a constant. It is added to an excess hydrochloric acid solution with the same concentration. Alright, so concentration is not playing a role here. I don't see any statement here that talks about the division of the magnesium. So we're just going to have to look and see where we go at. And then the first time I read this question, I completely missed that they said at STP. And when I had to do calculations later, I was like, but which molar volume? Oh, right, STP. Okay. They give us a graph, and they've got volume of hydrogen gas produced, be careful, in cubic centimeters, divide by or over, independent, the time taken, and they give us there 40 seconds there, and you can clearly see that that 40 seconds is there where no more hydrogen gas is produced for experiment 1. Experiment 2 takes a little bit longer to get there. The experiment 2 is a little bit like me. It's a more time learner. It definitely is a little bit slow on the uptake. Alright, and then very typical of practical questions, they ask you like what apparatus do you use or anything like that. So we are collecting gas, so we are using a gas syringe. Right. Define the term rate of reaction. Be careful here, you cannot use the rate at which. So you've got to say per unit time. Alright? Then the rate of reaction is the change in concentration of products or reactants per unit time. Alright, a very simple one, 2 marks or 0 marks. Then a relatively simple calculation. Calculate the average rate in cubic decimeters per second at which hydrogen gas is produced. Okay, so whenever they give you in question 5 a rate question and they ask you to calculate rate, they will give you the unit. And with this unit, you go and you figure out what is at the top and what is at the bottom. And you'll see here, cubic decimeters, volume of gas, divide by seconds, per second, divide by time. Just be careful, the graph, which now you can't see, is in cubic centimeters, so you are going to have to convert by dividing by 1,000. Okay, we are working with products, so it is a positive formula. If you were working with reactants, there would be a negative in there. Alright, so formula, then from the question, from the graph, at the end, at 40 seconds, there is 50 cubic centimeters, which is the same as 0.05, and we start with nothing. Plug that into my calculator. My calculator is very clever. It knows that I want things in scientific notation, so it gives things to me in scientific notation. 1.25 times 10 to the power minus 3, but if your calculator gives you 0.00125, your answer is still correct. They are numerically equivalent, or actually equal. Alright, don't forget the unit. My favorite question in the whole wide world, stoichiometry. I could do stoichiometry all day, every day, from the morning to the evening. Alright, 2 grams of magnesium was used for this investigation. Calculate the percentage purity. Very important. When you're calculating percentage purity of a reactant, you have to work backwards. You have to start at the back with the products and work your way forwards. Okay? Because your reactants are impure, you cannot start with reactants. If they are asking you to calculate percentage yield, that means that you're only getting a percentage of the end product out. And so you have to start in the front. Okay? So, I have to work backwards. I know that I get given a volume of hydrogen gas. Stoichiometry is all about taking things to mole. So the first thing I'm going to do is I'm going to take that 0.05 cubic decimeters of hydrogen gas at STP, so divide by 22.4, and I'm going to calculate how many moles of hydrogen gas that represents. And again, clever calculator, absolutely knows I love things in scientific notation. Again, guys, if your calculator gives you 0.002 and change, your answer is numerically the same. Obviously, this is an in-between answer, so you don't have to write a unit. I just like to be able to figure out what I did when I'm going over my question paper later if maybe I made a mistake. Alright, so step 1, whatever physical quantity to mole. Step 2, mole ratio. Beautiful. Hydrogen gas, magnesium 1:1. So the number of moles of hydrogen gas that formed is equal to the same as the moles of pure magnesium that reacted. Alright, now you need to remember that percentage purity, percentage yield, all of these guys, they are percentage mass, percentage volume, okay? They are physical quantity. So you cannot work it in moles. You have to take it back to mass. So I'm going to take the moles of the pure magnesium Oh, I didn't plan this page properly. And I am going to convert it into mass of magnesium. And now I just want you guys to realize that as far as possible, I just leave these values in my calculator. So instead of clearing it, all I'm going to do is see that it's that times 24. And so I'm just going to plug that into my calculator, and then my answer is more correct than if I keep on clearing my calculator and writing down the new value the whole time. So, the mass of magnesium. This feels like a very, very wrong answer, but, you know, I'll go with it. 5357 grams. I'm just going to double check that I didn't do something very silly. No, I didn't. Yay! Okay, that's what the memo gets too. Right, so percentage purity is mass of pure substance, the magnesium only, divide by the mass of the sample times 100, because it's percentage. I'm going to try and just leave it bigger for now. And again, when I'm doing my calculation, I'm going to leave that in there, divide by 2, and then times by 100. And so that final answer is going to be as correct as I possibly can make it. Okay, so the percentage purity of that sample is tiny. 2,6 now, 785 and change. If you are good at rounding, then at this point you are going to write 2,68%. If you are not good at rounding, you write down the first 3 decimals as it appears on your calculator, and you whack a percentage sign behind it. Both of those answers are correct. Okay. Sorry guys, I get extremely excited when I get to do stoichiometry. Makes me very happy. Alright, so heavy marks, 7 marks, but if you just start with what you have and work your way backwards, you're fine. Okay. Then they throw a Maxwell-Boltzmann curve in here. Why not? And they keep on reminding us that they are going back to experiment 1 and experiment 2 the whole time. Okay, I'm just going to zoom in. I'm sorry, look away now. Okay, and let's get the zoom. Autofocus. Perfect. Alright, so Maxwell-Boltzmann. And they keep on reminding us we're going back to experiment 1 and experiment 2. The experiments they give us right in the beginning of the question. Okay, so experiment 1, experiment 2, only now they're calling it A and B, and you cannot say that A is equal to 1 and B is equal to 2. Don't make that mistake. Okay. They want to know which factor are we investigating. If we look at this Maxwell-Boltzmann curve, right, the area under graph A and the area under graph B are similar. I'm not saying they're the same. They are similar. Right, so we've got the same number of particles going on here. There's no indication that we are moving an activation energy, which means that we are not dealing with a catalyst. And so, ladies and gentlemen, the only other thing that a Maxwell-Boltzmann can very clearly show us is that there is a temperature change, right? And so the factor affecting the rate of reaction is the temperature. Then, which curve, A or B, represents reaction 2? So I, again, went back and went, okay, reaction 2 is our more time learner. It takes longer to reach the end of the reaction. It still got the same amount of volume, guys. It just took a little bit longer to get there. So, experiment 2 is our slower rate. And we all know that if I decrease the temperature, I will get a lower rate. Maxwell-Boltzmann, if the peak of the curve is more to the left, then it's a lower temperature. If the peak of the curve is more to the right, then it is a higher temperature, even though the height of the peak is different. That's not the point. The more to the right, the peak of the curve, the higher the temperature. So, the curve here that shows me the lower temperature is curve number A. And then they want you to explain that, right? So very important that you explain why A is the lower temperature and 2 shows us why it is the lower temperature. Okay, and very specifically here, refer to the collision theory. Collision theory says that if particles are going to react, they must collide. They must collide with the correct orientation, which we have no way of dealing with in grade 12, as well as enough energy. Okay, so less particles for A, the curve with a lower temperature. Less particles will have enough kinetic energy in order to have that activation energy. And you'll see I typixed out all over the place because my words ran out. I didn't know how to otherwise word it. It still feels a bit long, but that's what I came up with. Okay, and then very important that you either say that the number of effective collisions per second will increase or decrease in this case. A lot easier is to say frequency. The frequency of the effective collisions will decrease or be less. Alright, so that was the longer question, not particularly hard, although I think the Maxwell-Boltzmann is a little bit trickier. Then I just want to point out to you guys that even if you could not do the stoichiometry, you could do the Maxwell-Boltzmann. So please do not leave questions out just because you couldn't do 5.4, now leave 5.5 out. Okay, that just not smart working. There was only one multiple choice question for rates of reaction. A reaction of copper to carbonate with excess hydrochloric acid is used to investigate the rate of the reaction. Balanced chemical reaction. So we've got a solid, we've got an aqueous solution, and that forms an aqueous solution and liquid and a gas. Okay, so my logical brain said that either the solid is going to get used up, but that's going to be really hard to measure because if this is a closed system, then the mass of this guy is going to stay the same because it's a closed system, mass is conserved. And then the other option that I saw is that you have a gas that forms. Now gases form bubbles, bubbles rise to the top, gas can be collected. Okay, so the rate of the reaction can be experimentally measured by measuring. You don't know visually how much hydrochloric acid is used. You cannot visually see how much water because a lot of this is aqueous. And temperature, well, ladies and gentlemen, you cannot do that for this equation. I'm not saying you can't do it, but for this equation, there's no mention of whether it's endothermic or exothermic and by how much and all of these things. So the very easy and obvious answer is because you only have one gas that forms. Even if you had more than one gas that was produced, you could have just gathered the volume of gases produced, and that would have given you the rate at which product gets formed. Alright, so nice and easy. Question 5. Right, now we get to question 6. Oh, no, I'm not even going to finish that sentence because every grade 9 learner everywhere in the country is jumping up and down. I can even hear them in my class, even though they're not physically the grade 8s and 9s sitting in my class doing that thing that you guys do. Okay, anyway, question 6, equilibrium. I know a lot of you don't like equilibrium. Don't leave out the entire question just because some parts of equilibrium is hard, alright? But I completely understand if equilibrium intimidates you. It does intimidate me sometimes too. It is very easy for them to come up with very interesting equilibrium application questions. Okay. Carbon reacts with an unknown amount of carbon dioxide in a sealed 2 cubic decimeter container at temperature T. The equilibrium constant, oh, nice of them, hey, is 0,2, and they give us a balanced chemical reaction. At equilibrium, the concentration of carbon monoxide, that's a product, is formed to be 0,04 moles per cubic decimeter. Okay, just read it again. They say carbon reacts with an unknown amount of carbon dioxide. Can you see that they are hiding that they are not putting any carbon monoxide in that container at the start of the reaction. Okay, anyway, so they want to know, can the situation be referred to as a closed system? And I point out there the word sealed. The word sealed means, yes, it is a closed system. Now, that too there jumped out at me a little bit because they like to do this with acids and bases, where they say explain your answer, and then technically speaking, that strong acid, strong base, weak base question. So just watch out if you have to only write one word, that they're not winking, nudging at you to actually get to what is the definition of a closed system in this situation. Okay, so I would definitely here write that it is a isolated system. It's isolated from its surroundings. It's closed because it is isolated from its surroundings. They did give on the memo the 2 marks for sealed, but I just feel a little bit uncomfortable with it. Okay, and now we get to the calculation. Alright, so I do first aid. I cannot work with a RICE table because then I want to put my feet up, because RICE stands for rest, ice, compression, elevation. It's got no place in chemistry. So I use a MICE table. Mole ratio, initial change, and equilibrium. Comes down to the same thing. Okay. You will notice that I have a double line underneath my equilibrium arrow. That is simply because I am incredibly good at forgetting what part of this reaction is reactants and what part of this reaction is products, and so I make it very obvious to my eye as I'm moving across. Okay, so my mole ratio is pretty simple. 1 mole to 1 mole gives me 2 moles. And then again I go back to the question, and they say carbon reacts with an unknown amount of carbon dioxide. So I don't know how much carbon, I don't know how much carbon dioxide, and I don't know how much carbon, but there's a solid there, so the chances are it's not going to matter. I only drew this line a little bit later when I realized it really doesn't matter, and they wink wink nudge nudge that there was no carbon monoxide in that container. Alright, now as I move down, I remember that they said at equilibrium the concentration of carbon monoxide is found to be 0.04 mole per cubic decimeter, so I write that in there. And then I like to just put my change in. I know some of my colleagues get a little bit of, I wouldn't say upset, but always say to me, don't use X because you're going to run out of like unknowns and things, and sometimes when you have to plug it into a Kc value, you run into trouble. But I really just need to keep in mind that 1 mole of that, it reacts, so it gets less by 1 mole, and this guy gets more by 2 moles. My brain needs to see that. Okay, then the next thing that I remembered is that I have a Kc equation, right? The concentration of the carbon monoxide squared, because it's to the ratio, mole ratio 2, divide by the concentration of the carbon dioxide, it's just to the power 1, and then remember that in Kc equations, Kc calculations, specifically this part of it, liquids and solids don't count. We assume that their concentration is 1. And then I plug in here, they gave me the Kc, and they gave me the concentration of the carbon monoxide, which means here I can calculate the concentration of the carbon dioxide. I have to do a bit of math miracle here. This goes up, that comes back down, and so it's 0.04 squared divide by 0.2. Oh, lovely. I actually think it's going to be worth putting it in a decimal form just for this little moment here, but you could obviously write it as 8 to the power minus 3, but anyway. And so this is going to go up there, 0.008 mole per cubic decimeter. Now, I am now going to switch to a different color pen because now we're doing the whole calculation thing. Purple might work, I don't know, let's see. So the first thing I'm going to do here is I'm going to take the concentrations to moles. I struggle to think in concentration, guys. I don't know why. I'm sorry, I can't explain it to you. I've tried, but I just find it a lot easier to work in number of moles that gets used. So to go from concentration to number of moles, you're going to remember that concentration is moles divided by volume, and we want moles. We have volume and concentration, so number of moles is equal to concentration times volume. So here they tell me up at the top that the container has a volume of 2 cubic decimeters, so it's 0.08 times 2, and that gives me 0.016 moles, and 0.04 times 2 gives me 0.08 moles. Alright, now I am going to use this last column because it's got the most info in it, and I'm going to work out, hypothetically speaking, what x is. So 0 plus 2x gave me 0.08, and so x has to be 0.04. And I'm going to take this 0.04 down there and go minus 0.04. Okay, this gap here is the question. The question is calculate the number of moles of carbon dioxide originally in the container. This is what I want. Okay, and again, I've already used an X. I don't know, do you guys want to use an A? You want to use a C? Oh, our teachers all over the world are going to get very upset. I'm going to use a C. I don't know why. Oh, wait, no. Let's just write it out. The number of moles of carbon dioxide in the container initially. Okay, so if I want to work that out, I'm going to say the number of moles of carbon dioxide initially in the container minus 0.04 moles, because that's how much got used, is equal to 0.016. Math manipulation. Luckily, that is not a hard math manipulation. So I'm going to double check that I agree with the answer. Indeed, I do. The number of moles of carbon dioxide initially in that container is 0.056 moles. And of course, at this point, you are free to round that off to 0.06, although it is a little bit risky. Okay, right, so that was how they used KC. Really nice question. It's about finding all the information from the question paper, plugging it into your table, and then figuring out what you can figure out, quite literally. Alright. Almost there. This question's got a few more bits and bobs on it, and then it goes to grade 11 questions, so that's going to be nice. Okay, so the first question they ask is the 6.4. Is the yield of carbon monoxide high or low? Remember, yield for equilibrium, you go and look at that. KC, I would have, in my brain I'll answer these questions other way around anyway. So, the Kc value is less than 1, meaning it is a fraction. If the Kc value is 1 or more, the reaction is product favored, so it has a high yield, right? The product here is carbon monoxide. But this Kc is less than 1, it is a fraction, and so it has got a low product yield. It is reactant favored. Alright. Now, a question that I definitely answered wrong way around, 6.6. They ask, they say, when the temperature is decreased, the yield of carbon monoxide decreases. They ask whether or not the forward reaction is exo or endo, and then they say use Le Chatelier. Right, there's no ways I could have done 6.6.1 first, and then argued 6.6.2. So, this is how I did it in my head, but I've said to my learners that this is like literally a one-word answer. So write 6.6.1, leave a line open, argue 6.6.2, and then go back to complete. Whoops, sorry guys. Fill in 6.6.1. Alright, so I start by saying a decrease in temperature favors the exothermic reaction. Fact, right? Not negotiable. That is true. Then, if I look at this reaction specifically, when I decrease the temperature, the yield of CO2 decreased, which means that the reverse reaction was favored. There was a decrease in product. Okay. So if a decrease in temperature favors the exothermic reaction, and in this example, that was the reverse reaction. That means the reverse reaction is exothermic, which means the forward reaction is endothermic. Okay. I love this temperature argument. It's so nice. Okay. Now we get to the grade 11 part of the question. A potential energy versus reaction coordinate graph. So you need to use that it's endothermic and basically draw a reaction coordinate graph for an endothermic reaction and add all your labels. And of course, I added the labels, include the following in the graph, that. And then I read that sentence. Write down the actual formula of reactants and products on the graph as labels for these energies. Right, so I was in grade 7 and my grade 7 teacher taught me always read the whole question before you start answering the question. But I know when you guys get stressed, you try and not forget what you were asked to do. So that's why I left it. I wanted to show you that you're not alone. Adults make silly mistakes too. Alright, so that was question 6, equilibrium, the long questions. Alright. You guys have gone very quiet. I think you have taken your Friday afternoon nap, which I absolutely do not blame you for. What I am going to say is that YouTube has a chat function. So if you decide to watch this video later, you can always pop a couple of questions in the chat. I am busy tutoring at the District East Matric Intervention all of tomorrow from 8:30 to 3:30. But what I will do after I have tutored, or even in the lunch break, I will quickly pop onto this video and check if there's any questions, queries, comments. And then I'll do the same Saturday evening when I get home, and again on Sunday afternoon. Those of you who are at Protea Heights, you, of course, most of you have my WhatsApp number, so you are welcome to WhatsApp me, send me photos, send me voice notes, those type of things if you need support. Alright, guys, we have got one question, one multiple choice question for this topic. Alright, so they ask, which of the following statements is not correct for equilibrium? And they start by saying, equilibrium is reached in a closed system. That is a correct statement. At equilibrium, the concentration of reactants and products are constant. That is also true. At equilibrium, the concentration of reactants and products is not necessarily the same. Now that is also true. And then D very clearly jumps out as being wrong. At equilibrium, the concentration of reactants is equal to the concentration of products. Ladies and gentlemen, at equilibrium, the rate of the forward reaction is equal to the rate of the reverse reaction. Okay, so D is the not correct statement. Alright, question 7, acids and bases. And then we've just got the 2 electrochem questions left. They're nice and short, nice and easy, nothing much to them. Alright, acids, bases. A standard solution of sodium hydroxide with a pH of 13,4 is used to neutralize a 3,125 cubic centimeters, careful there, of a 0.4 mole per cubic decimeter solution of sulfuric acid. Sulfuric acid says high again. Then they give us a balanced chemical reaction. Like I've said to you guys, the chances of them giving you balanced chemical reactions is very, very high. Right. Then they start by saying define the term standard solution. I thought that was a very interesting question for acids and bases. With acids and bases, there are really a whole bunch of definitions that you guys need to master. So pretty please, you've got the entire weekend. I know you guys are also writing other subjects next week. Please don't. I love chemistry, so I really do want you guys to take the time over the weekend and at least master all your definitions. Okay, so a standard solution is a solution of which the concentration is known. That's simple. Okay, then very typical question for acids and bases, these two that go together. Is sodium hydroxide a strong or a weak base? Guys, it is a group 1 metal hydroxide, which means it is definitely strong. Explain why. Sometimes they mean and they just ask this for one question, for 1 mark. Whether they ask it for 1 mark or for 2, like here, you write out all of this. It dissociates. It's a base. It dissociates completely. It's strong in water. It's a base, so it forms hydroxide ions. It is strong, so it forms a high concentration. Okay, again, guys, this is straight from your exam guidelines. Then 7.1.4, they start asking the calculations. I originally thought this was like a Stoichy type question because of the amount of marks, and then I realized, oh no, it's just the KW. For those of you who I don't teach regularly, I do not encourage the POH plus pH is equal to 14 method. The reason why I don't encourage that, even though you're going to find it on many YouTubes and in many textbooks, is it is not the way that it is explained within the CAPS document. And if you look at the exam, equation pages, they give you this log minus log of the hydronium and the KW, right? Nothing had stopped them from also giving you POH and then saying that POH plus pH equals 14. So I really would just be careful in using that in a C exam, even though I completely understand where it comes from, and you know, mathematically it's completely correct, and it is also scientifically sound. Anyway, right, so you can see I thought it was Stoic because I started writing down the equation. Alright, so we start by saying that the pH is equal to minus log of the hydronium concentration. Then you say the pH is equal to 13,4 and minus log of H3O plus. Now, log is the inverse of 10 to the power of. So if I have the log, then I go 10 to the power of minus whatever the pH is. And my calculator says the answer is 3, where do I need to write it? 3,98107. You can write as many decimals as you want. 5 is normally sufficient. Times 10 to the power 14. This is concentration, so it's mole per cubic decimeter. Of course, you do not have to write the unit there. It's an intermediate answer. And then to go from hydronium to hydroxide, we need to use KW. So I know that my hydronium concentration is 3,98 and change times 10 to the power minus 14 times the hydroxide concentration, and that's equal to 1 times 10 to the power minus 14. You could get away with just writing 10 to the power 14. Now we want to get the hydroxide on its own, so we're going to take this value that we calculated and bump it over. So it's going to become divide by. So in my calculator, I'm going to say 1 times 10 to the power minus 14. And I'm going to divide that by the previous answer. No, I'm not. So I did the silly thing. So now let's just put it in a bracket. I I always get a little bit worried when I am busy doing exponents and things, just because I always worry that I'm telling my calculator to divide an exponent by a bigger number. Okay, so I just want to double check that I didn't do something very silly. No, memo gets the same concentration. I get 0,2511, so I'm going to drop that, mole per cubic decimeter. And just as a reminder, the sodium hydroxide concentration is the same as the hydroxide concentration. Why? It is a strong base, and there is one hydroxide for every 1 mole. There's not a 2 somewhere hiding weirdly, like for example with the diprotic acids. Okay, here we get to the stoic question. Makes me so happy. Right, calculate the volume of sodium hydroxide required to neutralize the acid. You'll notice I didn't even bother writing down my products because they don't matter, because in this situation we are working with the volume and concentration of reactants all the way through. Alright, so that's literally where I'm going to stick. So I have the volume and the concentration of the sulfuric acid solution, and in the previous question I calculated the concentration of the sodium hydroxide solution, and they want me to calculate the volume. Now, all of you smart people sitting here, I know, I am well aware that it is possible to do this entire calculation in one step using the titration formula. Alright, I'm well aware. However, if you forget that there's a mole ratio involved and that titration formula only works because of the fact that it includes the mole ratio and all of the weird volumes that you then don't have to convert back from cubic centimeters to decimeters, although then you run the risk of not being able to do stoichiometry. Okay, that is the only reason I do not use that formula. I know of it. I know my method is longer. My method works with moles. Why? Because moles is king. Okay, so I'm going to take the concentration of the solution to moles. They gave me the 0,4 moles per cubic decimeter. They gave me 3,125 cubic centimeters. So I have to divide that by 1,000. So it's going to become teeny tiny, right? Now, for the number of moles, it's going to become multiplication. So 0,2 times 0,003125. Tiny number. That's okay. So I have got a total of 1,25 times 10 to the power minus 4 moles of sulfuric acid. Right. Then I'm going to use a mole ratio. And here you will see that it's a 1 to 2. So this is the number of moles of sulfuric acid. So I have to multiply that by 2. Again, weird tiny number. Multiply the 1,25 times 10 to the power minus 4 by 2. So I am going to need, or the reaction requires, 2,5 times 10 to the power minus 4 moles of sodium hydroxide to react, right? In the previous question, I calculated that my solution of sodium hydroxide has a concentration of 0,25. I now know that that solution needs to contain 2,5 times 10 to the power minus 4 moles, and they want to know what volume is that. So if you look here, I'm going to end up dividing that really tiny number by 0,25, and the answer is 1 times 10 to the power minus 3 cubic decimeters. And because I do this every day, all day, that is equal to 1 cubic centimeter. Okay. Oops, no. Double checking that. Yep. Okay. But you don't have to convert it to cubic centimeters. You can just leave it in cubic decimeters. Dum dum dum. Alright, we've got one more calculation left for acids and bases. And then we've got two multiple choice for acids and bases. And then we are going to do electrochemistry in one foul big swoop. It is 10 to 5, so we are very well on our way. We will be done here, I think, before 6. Anyway, a laboratory technician neutralizes an accidental spill by pouring 5 grams of baking soda on a 50 cubic centimeter hydrochloric acid solution. The acid solution is 1,6 moles per cubic decimeters. Those of you who are wondering why it sounds like my attention is split into 20 places, it is because it is. I just need to let our groundsman know that I am still in the school because I don't feel like sleeping here tonight, although my classroom is really, really hot. Sorry guys, give me half a second. I just want to make sure that security doesn't lock me in. That's really not something I feel like dealing with. Alright, calculate the pH of the final solution. 7-mark question. Now guys, here is where I often say to learners, it is fine if here the wheels come off. Okay? Because this is a big question. It's a lot of marks. There's a lot of things in here. Now if I look at this question, I can see that 5 grams of baking soda is something that I can go and calculate. I can go and calculate the number of moles of baking soda in 5 grams. Okay, so baking soda, sodium 23, hydrogen 1, carbon 12, oxygen 16, and there are 3 of them. So baking soda has a molar mass of 84. Sorry guys, not the visualizer there. So 5 divided by 84 is 0,0595. Let's leave it there, moles. Okay. So, I have taken baking soda to moles of baking soda. I can also do that with the concentration of the hydrochloric acid. So, the number of moles of the hydrochloric acid, just going to remind you that moles is equal to concentration times volume. So, 1,6 for the concentration, times by, careful, it's in cubic centimeters, divide by 1,000, 0,05, right, so 1,6 times 0.05, sorry guys, I'm just after yesterday where the memo was a bit out, just double checking my thinking and working, moles. Alright, so, it is very clear that they react in a 1-to-1 ratio, but I also didn't chuck a 1-to-1 ratio here. So, can you guys see that there's going to be hydrochloric acid left over, but that all the baking soda is going to be used up? How much hydrochloric acid? Well, from the 0,08 moles, 0,0, and I can see the memo rounded, but I'm going to just be a little bit careful right now and keep more decimals than I need to. So 0,0205 moles of hydrochloric acid unreacted. Alright. Now, I remind you, pH, concentration of hydronium ions. Okay? When hydrochloric acid ionizes, 1 mole of hydrochloric acid gives me 1 mole of hydronium acid. but I need the concentration. There I've got the number of moles, and then I go and find that I have a volume. So the concentration of the hydrochloric acid after the spill happened, after I neutralized the hydrochloric acid, would be the hydrochloric acid moles left over divide by the volume of the container, which remained the same. So the concentration is 0.41 moles per cubic decimeter. That is the concentration of the hydrochloric acid. I remind you, this is the same as the concentration of the hydronium ion. Ta-da! And now we're going to say pH equals minus log of the hydronium concentration equals minus log of 0.41, right, minus log of 0.41, make sure brackets are closed, 0.387. If you're good at rounding, then you round that to 0.39. If you're not good at rounding it, you leave it as 0.387. The memo is a little bit wonky. It says 0.3924, but anyway, there is your final answer. And that is the last longer question for acids and bases. Right. They decided it was a good idea to have 2 multiple choice questions for acids and bases in this case. Guys, just before we go to the last question, if you are a PHA learner, everybody listen. If you are a PHA learner, we, from the district side, must submit attendance, and I have done that in the form of a Google form. So, Protea Heights learners only. There is right now again, and now I'm going to actually pin that Google form to the top of the chat. Okay, so now the attendance register for the Protea Heights kiddos only is done at the top of the chat. The rest of you, it's not that I don't care that you are here. I've started getting to know some of you a little bit through the intertubes, but our district wants us to submit attendance register of who attends these extra sessions right before exams, and so I have to do that for them. It is a Google form that is set up to only accept PHA learners' email addresses. So I'm not going to give you access to the form. It is simply so that I know who by Monday morning, well, Sunday evening, has gone through this video in order to help them prepare. Alright, so back to the multiple choice for acids and bases. So 1.6, write down a conjugate base of the following acid. So, ladies and gentlemen, they are saying this thing, I think it is hydrochlorate. I wouldn't know how to exactly pronounce that. I'd have to look that up. But it loses a hydrogen ion. What is left over? That is the conjugate base. So firstly, that hydrogen goes away. So it cannot be A. There's a hydrogen. It cannot be B. It didn't gain a hydrogen, I promise. Okay. And the second you do that, there is only one answer. Okay. It's not about the charge, it's about the hydrogen and the charge. Cool beans. Then, the role of an indicator indicates the end point. The end point of your indicator needs to be the same or similar to, close to, the equivalence point of your chemical reaction. That's how you choose your indicator. Alright, those were 2 beautiful questions, nice and easy, lovely. Right, Guys, we are almost there. The electrochem questions, they are short, they are sweet, they all fit into one beautiful, easy page. If I were you, I wouldn't not start with them. I know you guys haven't written them a lot this year, but they are nice and easy. I see no reason why you wouldn't start with question 8 and 9 and get them over and done with, especially when you still have time. Okay. A learner has the following reagents to construct an operational galvanic cell under standard conditions: lead and lead nitrate. Can you see why I highlighted it in the same color? Silver and silver nitrate. Again, silver solution. And iron 3 chloride. Okay, odd child out. Then they ask you to define the term electrolyte. We also had this definition in the Metro East common paper. It is a solution that conducts electricity. They're looking for that conducts electricity, and very important, through the movements of iron. There are a number of others that they accept, but that is what I find the easiest one. Okay, now, using only those reagents, write down the cell notation of the operational galvanic cell. So I just want to point out to you, cell notation is anode, phase change, single line, and then the solution. Double line for the salt bridge, then this is where oxidation happens, and this is where reduction happens. So solution first, single line to indicate the phase change, and then the cathode, the electrode. Right, so I went and made table 4B all pretty. Lead in pink and silver in blue. Lead in pink and silver in blue. Top oxidizes, bottom reduces. Okay, I love table 4B because everything happens in a C form. Right, so that means that lead will oxidize and become lead 2+ in solution, salt bridge, and then on the other end, the silver solution, the ions in silver, will reduce, phase change, and become silver metal. Alright, so anode, phase change, solution around the anode. Salt bridge, solution around the cathode, phase change, and the cathode. Really, really easy. All of you can do that. Okay. Write down the formula of the substance that can be used in the salt bridge. So my question to you is, what's left? And the only guy that is left is iron chloride. And seeing as formulas don't take as long to write down as names, I am so writing down the formula. Okay, because they say name or formula. Last question for the galvanic cell. Yes, I know, right? That easy. Is calculate the EMF of the cell. You've got 3 possible formula. Pick one and always use that one. I prefer reduction minus oxidation. That's just how my brain works. Okay, we go back to table 4B. So, the E of the reduction, here's reduction, is 0,80 minus from the equation. The E of the oxidation is minus 0,13. Okay. Formula, substitution. Right. And then, answer is relatively simple, 0,93. Don't forget the units, volts. Done, dusted. Makkelijk. Really not much to it. There's only one multiple choice question, and I went and color coded again. We're talking about the zinc and the copper cell. Just to remind you, table 4B, zinc is at the top, so zinc is oxidized to zinc 2+, and then copper 2+ is reduced to copper metal. So the concentration of the zinc ions gradually decrease, not true. They increase. Concentration of the copper 2 plus ions in the copper half cell gradually increase. Not true. Copper 2 plus becomes copper. The intensity of the color of the electrolyte in the copper half cell will gradually decrease. Now, here I'm happy to say that I'm willing to accept that answer. Let's see what D says. Negative ions migrate from the zinc half cell to the copper half cell. Ladies and gentlemen, I had to read through this and it kind of went, don't know about that one. But ultimately, you need to remember that it is the salt bridge where ions are exchanged. They are not exchanged directly between the cells. And I think they put this in here for that electron transfer. So electrons are transferred from the anode to the cathode. Yes, in this case. So I think they tried to put that in there to get you guys confused with that. So the only possible answer here is C. Alright, ladies and gentlemen, last question. And then you guys can go and sleep and study some more. I know. I'm sorry. Alright, simplified diagram below represents electrolysis of copper chloride. I'm going to remind you that we have copper and chlorine, and there's the chlorine bubbles. Right. So, write down one safety measure which must be taken during the above process. Chlorine. Chlorine gas, guys. Chlorine. Okay, how do we make sure we don't get chlorine gas in our chests? We would work in a fume cupboard. And if you don't have a fume cupboard, you don't do this experiment. Okay? Chlorine gas is not fun. Alright, and then 9.2, why is this measure necessary? Because chlorine is poisonous. Remember that little tidbit because a couple of the electrolysis reactions produce chlorine. Okay, then, in what direction are the electrons moving? Now, you've got chlorine that becomes chlorine gas. Chloride ions that becomes chlorine gas. That releases electrons. The electrons come down the side, and then the copper 2 plus ions, because that's the only other thing that is in solution, become copper metal. So electrons are moving from Q to P. They are moving from Q, from Q to P. Sorry guys, this is what happens when my brain is too tired. Alright, write down the name of the substance that forms at electrode P. Again, there's only chlorine and copper in the mix, so this name would be copper, and I would go so far as to say that I'm going to call it copper metal, but anyway, I suppose copper is fine. Then write down the balanced net ionic equation for the reaction. Ladies and gentlemen, copper chloride forms copper metal plus chlorine gas. The gas is not necessary. Now, this is not ionic. Not ions. They expect you to split this guy into its copper 2 plus the 2 chloride ions gives you copper metal plus chlorine gas. That's what they're expecting. Okay. Now, if you wrote this, you would have gotten 1 mark for the products and no marks for the reactants. Oh, Kieran. Hi! Kieran wants to know if we need to know the different indicators and their names for pH. So, you need to know that strong acid, strong base, bromothiamyl blue. Strong base, weak acid, phenolphthalein. Then, if you go the other end of the spectrum, strong acid, weak base, methyl orange. You don't need to know their approximate pH switchovers. So you need to know strong acid, strong base, bromothermal blue. Strong base, weak acid, phenolphthalein. Strong acid, weak base, methyl orange. Okay, that's what you need to know. You don't need to know where their pHs change. You do need to know their names. Okay, that was that for this question. That one really quickly. Okay, and then again they give us two multiple choice questions. What was the energy conversion in an electrolytic cell? So, electrolytic cells take electrical energy and convert them into chemical energy. So I started by going, oh, electrical. Electrical to mechanical, no. I didn't know. It's electrical to chemical. Kieran, I do have your second question. I will get to it. Let me just get to question 1.10 quick. Alright, during the purification of copper, so quick little copper. Impure copper is at the anode. Impure copper is oxidized to become copper in solution. The electrons go from the anode through the power source to the cathode, at which point the copper in solution is reduced and the pure copper plates onto the cathode. Right, so impure copper is the positive electrode. True. Impure copper is connected to the cathode. Not true. Pure copper is the positive electrode. Not true. Pure copper is connected to the anode. Not true. True answer is A. Alright, so Kieran had another question, a follow-up question. So Kieran went and asked about esterification. And Kieran asked the question in a very open-ended way. So I'm going to not answer Kieran in an open-ended way. I'm going to answer Kieran in a grade 12 NSC way. For grade 12 esterification, you are only expected to work with carboxylic acids and primary alcohols. For grade 12 esterification, carboxylic acid, no branching on that carboxylic acid, and primary alcohol, and they won't give you an alcohol that is branched for the esterification. Straight chain carboxylic acid, straight chain primary alcohol will give you the ester. The reality is very different, but that is the limit for your grade 12 NSC exam. And then Joshua says he's having flashbacks of my esterification practical. I'm sure Mrs. Tucker, who is our current acting principal here, and our deputy principal and in charge of discipline at the school. She is also a physics sciences teacher. I know Mrs. Tucker was not particularly impressed with my choices of smells because Mrs. Tucker really dislikes the smell of banana. So everybody knew when their ester smelled like banana because she couldn't cope with it. It is my pleasure, Kieran. I hope that answered the question. Now, for the PHA kiddos, again, I say most of you have my WhatsApp number. I did send a message in the broadcast group earlier today, so if you don't have my number, pull it from there. I am teaching at the DEMI program, the District East Matric Intervention Program, tomorrow from 8:30 to 3:30. So if I'm not on my phone, it's because I've got however many kiddos in front of me. Josh, I'm going to see you tomorrow. But the rest of you that are not PHA students, that are just falling on this stream, or who watch the video later and would like to ask a question and you don't have a person to ask, you are welcome to leave a question in the chat. Remember, there is no such thing as a stupid question. If you don't ask the question, you still don't know the answer. And someone else who didn't ask the question, who didn't know the answer anyway, is too scared to ask. Okay? So in sciences, when you don't answer, there is no stupid question. If you don't ask the question, you don't know the answer. Alright? So you guys are welcome to leave a comment in the stream, not in the live stream, but in the actual comment section of the video. I will check comments tomorrow morning before I start tutoring Demi, over lunch, which is 11:30-ish, and then again when we're done with Demi, which is 3:30-ish. If there are any questions, then I will at you on my laptop and try and answer it as best as I possibly can. And then I will also check it on Sunday afternoon, probably around 2 o'clock-ish. I just do need some downtime to just rest. So if you have a question, if I didn't deal with something in the live stream, let me know. Every single PHA learner, you must please complete the attendance register. We have to submit the attendance register to the Metro East District offices. Mrs. Tucker is away on a strategic planning meeting, so I'm not going to bother her over the weekend. I am going to send them to her first thing on Monday morning. So please make sure you have completed that by Monday morning. Everybody else in the stream, you really don't need to. I'm not going to give you access to the form. Karen, it is my absolute pleasure. I hope you guys have a good weekend. Today's question paper looked good. I hope that you feel a bit more confident. Spend the weekend resting and studying. Be productive and good luck. And know that my hopes and thoughts and prayers and all of these things are with you guys the entire time you are writing on Monday. So I hope everybody has a lovely weekend. Ciao, bye.